Welcome to my YouTube channel, Techie Sang.
We are going to detail memory management in embedded system, that is ARM architecture and Raspberry Pi in detail. Basically, we have seen what is embedded system. From whatever the previous slides, whatever that we have discussed, we came to know that its characteristics, that is its dedicated function. Embedded system will have dedicated function or specific task. That is what we have seen. And next thing is, if time was merged or considered along with embedded system, then it is no more embedded system. It is real-time constraints. Okay. It consists of real-time constraints. And resources limited. Depending upon the application, we have to choose the resource. Okay. And next thing is that examples of embedded system, we have seen IoT devices, automotive, industrial control. IoT devices, we have seen home appliances. We can use it, different cameras. We can place different cameras in the home or workplace or any buildings. Wherever we want, we can just place the camera. And that can be monitored from your mobile phone, and you may be in any place in the world. Okay, that is possible. If you have net connection, you can just access all the cameras. You can change the camera angle. You can just view it. You can speak the person who is standing before the camera. All this, it is possible using IoT devices. And next thing is that automotive. In sophisticated cars, if the car gets hit in any object, in that case, the airbags will be blown within a second to protect people inside the cars. Okay. These type of things, we have it in automotive. This is an embedded system. And industry control, PLC, everything, we can use it in instrumentation and control and everything. About how far the oil has to flow within the pipeline, everything we can control it using embedded system. Importance of memory management. Okay. The memory management, if resource is limited, that is memory, it may be RAM memory, it may be ROM memory, it may be flash memory. There are different types of memory, what we have seen it in earlier slides. Now, resource constraint in embedded system, if memory is less, you have to choose the application and you have to choose the architecture according to the memory that is available. Okay. For example, if it is image processing application, you cannot choose a low-end device, low-end architecture. That is impossible to do it. Okay. You have to, for image processing, it is a must that you have to go for DMA controller based architecture. And second important thing in memory management is that impact of poor memory management. That is, crashes that occurs, instability, performance issues. Okay. In case of any crashes that occur, it has to recognize that crashes has occurred. Okay. That has to be taken into care. That is, crashes, instability, and performance issues. Everything should be taken into care. And the memory management, whatever memory we have, whether cache memory, RAM memory, or ROM memory, whatever memory we have to allocate the memory efficiently. and we have to deallocate the memory efficiently, and it has to be organized properly. All this we have to do it in case of memory management. This is very important factors. These three factors are important factors in case of memory management. Focus on ARM and Raspberry Pi. In case of ARM architecture, it is dominant in embedded system. We use widely ARM architecture in embedded system. Raspberry Pi, a popular ARM-based single-board computer for prototyping and development. It acts similar to that of it itself. It is a mini computer. Raspberry Pi, it itself, it is a mini computer. You can implement any application using Raspberry Pi. And we have to focus on this because it is very important in practical applications. That is where you are studying Raspberry Pi, and all these concepts is very important in case of real-time applications. Now, fundamentals of memory in embedded system. The basic types of memory is that random access memory and read-only memory. Random access memory, it is a volatile memory, and read-only memory, it is non-volatile memory. In case of random access memory, there are two types, static RAM and dynamic RAM. In case of static RAM, it is made up of flip-flops. It is very bulky. In case of dynamic memory, it is made up of each bit is stored as capacitor. In case of dynamic RAM, in case of static RAM, each bit is stored in the flip-flop. So the size will be bulky in case of static RAM, and the size will be compact in case of dynamic RAM. But the problem in dynamic RAM is that since it is a capacitor, once it is charged, immediately it will start discharging immediately. That is the problem that occurs in case of dynamic RAM memory. So to overcome this problem, what we will just do is that we will place a refreshing cycle for inside the dynamic RAM. By this, we retain the values in the capacitor. Whichever capacitor has values, that values will be retained in the capacitor because of refreshing cycle that concept used in dynamic RAM. Volatile nature. It is used for active data and program execution. What it does is that whatever data the CPU processes, that is intermediate data and everything, whatever data that is processed by CPU, that will be thrown into RAM memory. And in case of read-only memory, what we have is that whatever the program that is written, whatever the program need to be executed or the functionality need to be designed, that will be deployed inside the read-only memory. Okay, in case of read-only memory, there is flash memory, which is made up of universal gates, NAND and NOR gate, and EEPROM, electrically erasable programmable read-only memory. You can erase this memory electrically. You can erase it n number of times. That is possible using electrical erasable programmable read-only memory. It is used for storing boot code, firmware, and persistent data. Okay, in case of ROM memory. So when CPU executes whatever the functionality it has to do, that program has to be deployed inside read-only memory. The data that is fed in or fed out, those data that will be stored in the random access memory, it is a volatile in nature. Once the power is shut down, the data will be cleared. All the previous data will go off. That is the case of volatile nature. but the programs will reside inside the memory in ROM memory forever. Even if power is switched off, the program will be available in the ROM memory once we switch on the power. That is the specialty of read-only memory. Memory organization. The address spaces there are two types of address space. One is physical address space, another one is virtual address space. Physical, but normally what the CPU does is that it will generate its own address space that is called virtual address space, and then it maps with the physical address space. That is what it does. Okay, so whatever the program, whatever it needs to execute, it generates its own address space that is called virtual address space, and then it maps with the physical address space. Memory map. It is regions of code, data, stack, heap, and peripherals. Now, in case of the data, whatever that is available, that will be stored in the stack. That is, last input data will be taken first. The stack stores the data. The stack stores the data that is executed by the CPU. Similarly, it happens in case of heap, and we will discuss this in detail. Stack, heap, and peripherals we will discuss in detail, and also linker scripts and the role in the memory layout we will discuss in detail. In case of memory hierarchy, we have registers, the cache memory, maybe L1, L2, main memory, secondary storage. All this is available as available in the memory hierarchy. And the trade-off that we are going to see is speed versus capacity trade-off. This is the basic fundamentals of memory in embedded system. So first thing what we have to do is that we have to see types of memory. And next thing is you have to organize the memory. And organize the memory, how you are going to organize, whether it is virtual space or physical space, what type of memory it is, that we have to see. And how we are going to map the memory, we have to see. And linker scripts. And then memory hierarchy. What are the memory that is available within the architecture? That.
Thank you, friends.